Page 2 of your Chapter 7 study guide. Numbers 14 through 19, I give you a hint that you're going to need to use the sum and difference identities to find the exact values. Okay, so if I give you that hint, if you have your sum and difference identities handy, we're going to look at those. For 14 and 15, though, they look a little bit different than the rest. And basically the deal is, I have given you, for 14 and 15, I've given you the right side of your identity, and you're going to go backwards. So if you look at your sum and difference identities, obviously number 14 is the tangent identity, tangent sum and difference identity. So let's write that identity down. The tangent sum and difference identity will be tangent of alpha plus or minus beta is equal to tangent alpha plus or minus tangent beta all over 1 minus plus tangent alpha times tangent beta. So if you're going to notice, the problem that I gave you looks just like the right-hand side, right? All of this stuff looks like all of this stuff, except instead of alphas and betas, I have 86s and 41s. So that means 86 will be considered alpha and 41 will be considered beta. Well, I don't know what these things are, right? I don't know the tangent of 86 degrees. I don't know the tangent of 41 degrees. And that's the whole point, is that by the identity, I can consolidate this mess of a problem by rewriting this as the tangent of alpha plus or minus beta. Now, alpha I said was 86. Beta is 41. You just have to decide, are you adding or subtracting these numbers? And the thing that's going to give that away is the signs that are in the problem. Okay, so for number 14, we are given, they do tangent minus tangent, and then as denominator I have plus. So if I'm looking at the identity, the minus sign in the numerator and the plus sign in the denominator are both signs that are on the bottom of that symbol. So that tells me I need to use the bottom of the symbol to the left as well, which is going to be alpha minus beta. So that's what tells us that we need to be subtracting. So then if I continue to simplify this, the tangent of 86 minus 41 is 45. And then using our unit circle, we should know that the tangent of 45 degrees is just equal to 1. So we take our complicated right side, we simplify it, and get your value from the unit circle. Number 15 is similar. The obvious difference is that I give you radians instead of degrees. So you could change it to degrees now, or you can change it to degrees later, or degrees not at all. I notice that they have common denominators of 18. So I notice that I will probably be able to add and subtract them just fine because they have common denominators already. First thing to note is you have to figure out the pattern in which identity matches. So the pattern of this is cosine, cosine plus sine, sine. If you look at your sum and difference identities, this one matches cosine of alpha plus or minus beta equals, it matches this pattern. Cosine alpha times cosine beta minus plus sine alpha sine beta. So again, I give you the right-hand side of the identity. So you don't know how to find the cosine and sines of those angles. So the idea is to consolidate that to find the left side. Okay, so thing to note is alpha is just your first number, beta is your second. So I want to also figure out my sines. On the right-hand side, it's cosine, cosine plus sine, sine. So if I do the plus part of that symbol that's on the bottom, that tells me I will need to be using the minus on the symbol on the other side because it is on the bottom. So this is going to be the same thing as the cosine of alpha will be 23 pi over 18 minus beta, which will be 11 pi over 18. And again, you could have converted those to degrees first and then subtracted them. It doesn't matter. Either way, if I subtract 23 pi over 18 minus 11 pi over 18, I end up with 12 pi over 18, which reduces again to be cosine of 2 pi over 3. So if you haven't converted to degrees yet, you can convert 2 pi over 3 if you don't know it, if you don't know the cosine of this value. to multiply it by 180 over pi, and you will get 120 degrees. So the cosine of 2 pi over 3 is the same thing as the cosine of 120 degrees. Cosine is dealing with the x-coordinate, right? Cosine is x-coordinates on our unit circle. So the x-coordinate at 120 degrees is equal to -1/2. The sine of 105. Now, of course, I gave you the hint that you're going to be using your sum and difference identity, but the reason is because if you look at your unit circle, 105 degrees is not on there. So even if you know that the sine is, okay, well, that's my y-coordinates at that angle, we don't know the y-coordinate of 105 because it doesn't relate to one of our special right triangles. So what we want to do is, again, I prompted you to use a sum and difference identity. So if you look at the sum and difference identity for sine, you get sine of alpha plus or minus beta is equal to sine alpha cosine beta plus or minus cosine alpha sine beta. So if you look at it this way, you're like, there are two different angles. So 105 is not alpha or beta. You want to find what are two angles on your unit circle that add or subtract to be 105. Now, you very well could say, well, 105 degrees is the same thing as doing 100 degrees plus 5 degrees. And though you would be right, that isn't helpful either, because 105 are also not on the unit circle. So the trick is pick numbers on the unit circle that you know the sine and cosine values of that will help you find this once you plug it in the identity. So hopefully, after looking at your unit circle, you might be able to come up with the numbers 60 plus 45, because 60 plus 45 is 105 degrees. So if I now want to say, so if 60 is alpha and 45 is beta, so I'll have the sine of 60 plus 45. That means I'm going to fill in the right side of the identity, but instead of alphas and betas, I'm going to use 60 and 45. The other thing to note is in the identity, since we are adding alpha and beta, that is the sign on top. So I'm going to use the sign on top of the identity as well, which is plus, right? Because all of them are being added. So then that's going to be the sine of 60 times the cosine of 45 plus the cosine of 60 times the sine of 45. And then if you use your unit circle, you can gather these coordinates directly from there. Sine, we know, is the y value at 60, which is the square root of 3 over 2, times cosine of 45 is the x value at 45, which is square root of 2 over 2, plus cosine of 60 is 1/2, times sine of 45 is square root of 2 over 2. And now your job here is just to clean things up a little bit. We can multiply these fractions straight across. So square root of 3 times square root of 2 is the square root of 6. In the denominator, 2 times 2 is 4. Plus, over here, 1 times square root of 2 is just square root of 2. And again, 2 times 2 is 4. And now these two fractions have common denominators, which means I can add their numerators. Square root of 2 plus square root of 6 plus square root of 2 all over 4. Now, those are not like terms, right? Those radicals are not the same, so I cannot add them. Number 17, the tangent of 75 degrees. Again, the thing to note, 75 degrees is not on your unit circle, so your job is to figure out what angles add to be 75 degrees that are on the unit circle. So if we take our tangent sum and difference identity, we get tangent of alpha plus or minus beta is equal to tangent alpha plus or minus tangent beta all over 1 minus plus tangent alpha times tangent beta. So if you look at the numbers on the unit circle, of course there are many different answers, but I would say the easiest way to break up 75 degrees is to do tangent of 30 plus 45. 30 plus 45. So what that means is we need, in order to plug it in the identity, we need the tangent of 30 and the tangent of 45 degrees. So let's go off to the side and solve for those. Now, tangent of 45 degrees, you should be able to solve in your sleep. Square root of 2 over 2 over itself is going to be 1. Tangent of 30 degrees will be a little bit more challenging. We know that tangent is found by taking the y coordinates over the x coordinates. At 30 degrees, the y coordinate is 1/2 over its x coordinate is square root of 3 over 2. A stacked fraction like this could be rewritten as 1/2 times the reciprocal, which will be 2 over the square root of 3. 2 over 2 cancels, leaving me with 1 over the square root of 3. Now, 1 over the square root of 3 can be rationalized. So if we multiply it by the square root of 3 over the square root of 3, then we end up with the tangent of 30 degrees, which is going to be the square root of 3 over 3. Okay, so all of that was just like side work. So I'm going to leave it kind of blocked off. I'm going to use these values. Tangent of 45 is 1, tangent of 30 is square root of 3 over 3. Plug those in the identity. So again, if 30 is alpha, 45 is beta. And as far as signs go, I'm adding 30 plus 45. So if I'm adding alpha plus beta, that means I'm going to use the top sign in that symbol. So the top sign over here will be plus, and over there will be minus. So tangent of alpha is going to be the tangent of 30 plus the tangent of 45 all over 1 minus tangent 30 times tangent of 45. And then we're going to substitute our values in. So this is the same thing as, we know tangent of 30 is the square root of 3 over 3, plus the tangent of 45 is 1, all over 1 minus square root of 3 over 3 for tangent 30, times tangent of 45 is 1. Now, many of you can get to this point and then you start wigging out about all of the arithmetic. Don't. Okay, take things one step at a time. First thing I would do would take your fractions and be to add them. So focus only on the big numerator and the big denominator. So if I change this 1 to be 3 over 3, then I have a common denominator and I can add those numerator fractions together. So then if I add these, I get the square root of 3 plus 3 all over 3. In the denominator, I'm going to do something similar. I'm going to change that 1 to be 3 over 3. And then circled in green here, if I add those two fractions, numerator with numerator, I get 3 minus the square root of 3 all over 3. It may look like you've complicated things more, but you actually made it easier. We know by now if I have stacked fractions, I can keep my first fraction, square root of 3 plus 3 all over 3, and multiply by the reciprocal of the bottom fraction. So if I reciprocate the green fraction, I'm going to get 3 over 3 minus square root of 3. And then we know that multiplying fractions straight across, if I have 3 divided by 3, those cancel, leaving me now with the square root of 3 plus 3 over 3 minus the square root of 3. Now, we still cannot have radicals in the denominator, okay? So multiplying, typically when that happens, like if you look over here where we did the tangent of 30, typically you multiply by the radical over itself and you're done. But the problem with this one is that there is a binomial in the denominator, not a monomial. So you can't just multiply by the square root of 3 over 3, or square root of 3 over itself and move on. You're going to multiply by what is called the conjugate. So a conjugate is, in the denominator, you need to switch the sign and multiply by that over itself. Okay, so switching the sign will be 3 plus the square root of 3 over 3 plus the square root of 3. So this is called the conjugate. And then we're going to multiply this gray conjugate by the blue fraction. So what that means is in the numerator, so what I've circled here in blue, we're going to multiply those binomials times each other. So we're going to FOIL. So if I do that, first is going to be 3 square roots of 3. Outer is going to be square root of 3 times square root of 3, which is just 3. Inner, 3 times 3 is 9. And then last will be another 3 square roots of 3. In the denominator that I have circled here in green, I'm going to FOIL again. First, outer, inner, last. So first is going to be 3 times 3 is 9. Outer is positive 3 square roots of 3. Inner is negative 3 square roots of 3. And then the last term, negative square root of 3 times positive square root of 3 is just going to be negative 3. And then if I continue simplifying, in the numerator, if I add my like terms, 3 plus 9 is 12. 3 square roots of 3 plus 3 square roots of 3 is 6 square roots of 3. In the denominator, 3 square roots of 3 minus 3 square roots of 3 cancels, and 9 minus 3 is 6. And then if I reduce one more time, everything is divisible by 6. So 12 over 6 is 2, and 6 over 6 is 1. So your final answer would be, let me clean this up, 2 plus the square root of 3. Cosine of 17 pi over 2, if I want to use the sum and difference identity for this, the first thing I would probably do if I were you is go ahead and convert this radian into a degree by multiplying by 180 over pi. So if I do that, then I end up with 255 degrees. Now, again, 255 is not on your unit circle. So that's why I prompted you to use the sum and difference identity for cosine, which we've already used. So that's going to be the cosine of alpha plus or minus beta, which is going to be the cosine of alpha, cosine beta, minus plus sine alpha, sine beta. So 255, I need to break up into two numbers that I know that are on the unit circle to be able to help me plug into the identity and solve for the exact value. So again, there are lots of different options. I rewrote mine instead of 255 as 30 degrees plus 225 degrees to equal 255. So if alpha is 30 and beta is 225, that's what I'm going to plug in. The other thing to note is if I am adding my angles, alpha plus beta, that means I'm using the top sign in that symbol. So I'm going to use the top of the symbol on the right-hand side as well, which is the minus sign. So if I fill in the rest, this will be cosine of alpha is 30 times cosine of beta will be cosine of 225 minus sine of alpha is 30 times sine of beta is 225. And then using these values from the unit circle, cosine is the x value. So the x coordinate at 30 degrees is square root of 3 over 2. The cosine of 225 is the x coordinate at 225, which is negative square root of 2 over 2. Make sure that negative doesn't creep up on you. Minus sine of 30 is 1/2. Sine of 225 is negative square root of 2 over 2. So then if we multiply these fractions straight across, square root of 3 times negative square root of 2 will be negative square root of 6. In the denominator, 2 times 2 is 4. Over here to the right side, I have minus, or, you could, it depends on, or I'll leave it as a minus, actually. Okay, so minus, in this numerator, 1 times negative square root of 2 will be negative square root of 2. And the denominator, 2 times 2 is 4. So you can clean up your signs a little bit as well. Minus a negative is going to change to plus a positive. So this one will be negative square root of 6 plus the square root of 2 all over 4. Or you might see it as square root of 2 minus square root of 6 all over 4. So either one of these answers. Number 19, the sine of negative pi over 12. First thing I would do is convert pi over 12 into degrees. So if I multiply it by 180 over pi, I end up with negative 15 degrees. Negative 15 degrees. That looks like 75. Hold on. Negative 15 degrees. So again, I want to know what are two numbers that I can subtract or add to be negative 15 degrees. Well, Let's go ahead and write the sign identity first. I know that the sign of alpha plus or minus beta is going to be sine alpha times cosine beta plus or minus cosine alpha times sine beta. Okay, and two numbers that subtract to be negative 15 would be 30 minus 45 degrees. So then if 30 is alpha and 45 is beta, and I realize that I'm subtracting these two angles, alpha minus beta, I'm using the sign on the bottom, so I'm going to use the sign on the bottom over here, which is also subtraction. Then this will be the sine of 30 times the cosine of 45 minus the cosine of 30 times the sine of 45. Using my unit circle knowledge of these coordinates, the sine of 30 is 1/2. Cosine of 45 is square root of 2 over 2. Minus cosine of 30 is square root of 3 over 2. Times sine of 45 is square root of 2 over 2. Simplify these fractions, we'll multiply straight across. Square root of 2 over 2 times 2 is 4. Minus square root of 3 times square root of 2 is square root of 6. Over again, 2 times 2 is 4. Clean it up one more time. These fractions have common denominators, so I could rewrite it as square root of 2 minus square root of 6 all over 4. Number 20, use the half angle identity to find the exact value for cosine of 5 pi over 8. I give you the hint, use your half angle identity, exact value. Okay, cosine of 5 pi over 8. Again, we're used to kind of dealing with degrees. So if you want to go ahead and convert this to a degree by multiplying by 180 over pi, you're going to get 112.5 degrees. So if I prompt you to use the half angle identity, if you look at your reference sheets, your half angle identity for cosine is the cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha all over 2. So in order for me to figure this out, I have to know what is the cosine of alpha, and I have to choose plus or minus. So again, the key here is 112.5 is not on your unit circle. If it were on your unit circle, then you wouldn't need the half angle identity. You would just be able to tell me the cosine or the x value at that angle. Instead, I'm going to break it up to be the cosine of alpha over 2. So basically, what we can do is we can rewrite, instead of having the cosine of 112.5, I can rewrite that number as the cosine of 225 divided by 2, right? If I double 112.5, I get 225 divided by 2. So then, this looks like a scenario of alpha over 2, right? 225 over 2. So then if I plug that in the identity, that's going to tell me that the cosine of 225 over 2, so alpha over 2, is going to equal. Now, the whole plus or minus thing, here's the deal. The cosine of, not of alpha, we need the cosine of like this whole angle, right? The alpha over 2 is 112.5. So 112.5 is in quadrant 2. Cosine is my x-coordinate, and I know that x-coordinates in quadrant 2 are negative, which is why I'm going to choose negative. So now I'm going to have negative square root of 1 plus cosine of alpha is 225 all over 2. And then I just need to keep simplifying. So I'm going to have negative square root of 1 plus cosine of 225 is going to be negative square root of 2 over 2 all over 2. And then again from here, it's just going to be some algebra to simplify from the inside out. So I'm going to have negative square root of. I'm going to simplify my numerator. If I rewrite the number 1 as 2 over 2, and that's going to be minus square root of 2 over 2 all over 2, then I can subtract those now because they have common denominators of 2. So I can, what I've just circled here, I can rewrite as 2 minus square root of 2 all over 2. And then all of that is still all over 2. And then let's get rid of that stacked fraction. So this can be rewritten as negative square root of 2 minus square root of 2 over 2. Instead of dividing by 2, I know that that is the same thing as multiplying by 2's reciprocal, which is 1/2. And then if I multiply that straight across, I get negative square root of 2 minus square root of 2 all over 4. Now, side notes, radical rules say that fractions under a radical are not considered simplified. So if you remember that the square root, oh, Brewski, that's loud, that the square root of a over b is the same thing as the square root of a over the square root of b, then I can break up this problem further to be negative square root of 2 minus square root of 2 all over the square root of 4. And then we know the square root of 4 can be simplified. So your final answer will be negative square root of 2 minus square root of 2 all over square root of 4 is 2. And that would be your final answer. Number 21, given that the sine is 12 over 13 and that theta is between 0 and 90, it could equal 0 or 90. So again, the key here is just that we're in quadrant 1. Find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So let's start at the beginning. Sine of 2 theta, that is a double angle identity. So if you look at your reference sheets, recognize the double angle identity is 2 sine theta cosine theta. Well, as I start to plug this in, or as I start to look at what I have sine theta. Sine theta is 12 over 13, so all I need is cosine theta. So I need cosine theta. Well, I can use a Pythagorean identity, which says that sine squared theta plus cosine squared theta is equal to 1. Therefore, if I plug in, sine of theta is 12 over 13 squared plus cosine squared theta equals 1. I can solve for cosine. So 12 over 13 squared is 144 over 169 plus cosine squared theta equals 1. If I subtract 144 over 169 from both sides, I'm left with cosine squared theta equals 25 over 169. And then to get cosine by itself, I'm going to take the square root of both sides, which will be plus or minus the square root of 25 over 169. Now, I am in quadrant 1, which means I should choose the positive angle, or the positive ratio, and then the square root of 25 over 169 is 5/13. So I'm going to hold on to this value. Cosine of theta is 5 over 13. So let's go back to my identity, which is sine of 2 theta is 2 sine theta cosine theta. So that's going to be, if I go ahead and substitute stuff, that's going to be 2 times sine theta is 12 over 13. Cosine theta I just found was 5 over 13. And then if I multiply these three numbers together, I get my answer for the double angle. Sine of 2 theta is equal to 120 over 169. Next is, what is the cosine of 2 theta? Double angle identity, cosine of 2 theta is 1 minus, there are a few, by the way, but I'm just going to choose this one, 1 minus 2 sine squared theta. So I chose that one because I was given sine squared theta. So then if I substitute in what I know, I'm going to do 1 minus 2 sine squared theta. I'm going to plug in, I know sine is 12 over 13. Don't forget to square it, though. And then use PEMDAS to simplify. So it's going to be 1 minus 2. PEMDAS says take care of parentheses and then exponents. So I'm going to take care of this exponent. 12 over 13 squared is 144 over 169. So that'll be 1 minus 288 over 169, giving us our final answer for cosine of 2 theta, which would be negative 119 over 169. last double angle is tangent of 2 theta. That identity says tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. So I need tangent of theta. Need tangent of theta. Well, I already have sine and cosine. So if you remember that tangent of theta is sine divided by cosine, then that means tangent would be sine is 12 over 13 over the cosine we found earlier was 5 over 13. Then that means that our tangent is going to equal 12 over 5. Okay, so this is our tangent of theta value, 12 over 5. So then if I plug that in for tangent over here to the double angle formula, that's going to be 2 times 12 over 5 divided by 1 minus 12 over 5 squared. And then again, just use PEMDAS to simplify. In the numerator, 2 times 12 over 5 will be 24 fifths. In the denominator, that'll be 1 minus 144 over 25. This will equal 24 fifths over negative 119 over 25. And then if we take your 24 fifths, multiply by the reciprocal, that'll be negative 25 over 119. Then you will end up with, once that simplifies, tangent of 2 theta is equal to 120 over 119. Last question on this, number 22. Given cosine of theta is 8 over 17, where theta is between 3 pi over 2 and 2 pi, in other words, this is quadrant 4, find the sine of 2 theta. So I always like to write what it wants me to find. If it's asking me to find the sine of 2 theta, that identity, which we wrote earlier, is 2 sine theta cosine theta. Well, I already have cosine theta. I know cosine theta is 8 over 17. So the only thing that I need is sine theta. So if I need sine theta, again, I can use a Pythagorean identity. I can say sine squared theta plus cosine squared theta equals 1. And then I can say, okay, well, sine squared theta plus, I know cosine is 8 over 17 squared equals 1. So then sine squared theta plus, this will be 64 over 289 equals 1. If I subtract 64 over 289 from both sides, then I get sine squared theta is equal to 225 over 289. To isolate sine, I'm going to take the square root of both sides. So then I get sine theta is equal to plus or minus the square root of 225 over 289. Now, I'm in quadrant 4. In quadrant 4, sine, which is the y value, is negative. So that's why I know I'm going to choose sine theta to be negative, actually take the square root, 15 over 17. So I found sine theta. So then if we go back to our identity and we plug in our values now, then we're going to get sine of 2 theta is going to equal, so let me just rewrite it, 2 sine theta cosine theta. So that's going to be 2 times sine theta you just found is negative 15 seventeenths times cosine theta is 8 seventeenths. And then if I multiply all those things together, then I get that the sine of 2 theta will be negative 240 over 289. That concludes your Chapter 7 study guide for the most part. Again, I want to remind you that the solving equations in Chapter 7, Section 5, that homework assignment will double as a different part of your study guide as it was given to you after the study guide was made. So make sure that you review how to do those solving equations as well.